All right, so we are now on 2.6. Sorry, I know it says 2.5. That is a typo. It should say 2.6. All right, proving angle relationship. So 2.6, kind of similar to 2.5 in terms of, like we had the segment addition postulate. Now we've got the angle addition postulate. But there are also a lot of kind of reasons that revolve around angles being complementary or supplementary. We've got some with linear pairs, vertical angles, things like that. So these are all going to be kind of a new list of reasons that we can use in these proofs. And so again, when we think about all these reasons, all right, first thing I'd like you to do is pause the video, write down all of this stuff, okay? These can also be found in your textbook. If you want to look in your textbook, you can see all of them there. But this just gives an explanation of kind of what everything is, and then I just added a specific example for all of them, okay? So bottom line, when you're looking at these, so right now I'm assuming that you've paused the video and you've written all of these down. So you have all this written. When we go through this, we're thinking about what would be the statement and what would be the reason, okay? So the reasons are all of these bullet points, okay? These would go in the reason column. All right, so when you're writing your proofs, these are all the reasons that you would use. All right, the last two here don't really have a name. You're just gonna kind of explain that. You would literally say all right angles are congruent for your reason. Same thing with this. That's your reason. This is also your reason, okay? So there's no specific name for these bottom ones. You kind of got to write it out a little bit. But again, anything in purple would go in the reason column on the right side when you're doing a 2-column proof, all right? What would go on the left side in the statement column is like this, right? If we see that 2 angles add up to equal the total angle, the reason in purple would be the angle addition postulate, okay? So again, if they have like given information that angles 1 and 2 form a linear pair and then 1 and 2 are supplementary, boom, that's your supplement theorem would be the reason, right? So all of these examples would be, the blue would be the statement on the left side and the purple would be the reason on the right side. So hopefully that makes sense, okay? So the angle addition postulate, kind of similar to the segment addition postulate, is just saying that the angle here plus the angle here would equal the entire angle, all right? Supplement theorem, if 2 angles form a linear pair, remember linear pair is just when you've got 2 lines that intersect and they're the adjacent angles. So obviously 1 and 2 are the adjacent angles there. So we know if that 1 and 2 are a linear pair, then they are also supplementary, okay? We can't assume yet that they add up to 180. So just because they're a linear pair, I mean, obviously we know at that point they are going to add up to 180, but you first have to establish that they're supplementary, and then you can establish that they add up to 180, all right? So complement theorem next says if 2 angles form a right angle, then they're complementary. So again, just because 2 angles form a right angle, you can't say that they add up to 90. You have to first say that they're complementary, and then once you say they're complementary, then you can say they add up to 90. So there's kind of like an intermediate step that is kind of a little bit annoying. Like normally when we think about this, we're like, oh, these 2 add up to a right angle, so they're both going to add up to 90. We can make that connection in our heads, but in a formal geometry proof, you have to take the time to go from definition to definition. All right, it takes a little bit longer. It's a little annoying sometimes, but that's the process. All right, congruent supplements theorems. This says that if angles 1 and 3 are both supplementary to angle 2, that means that 1 and 3 must be congruent to each other. Next one is kind of similar. If 1 and 3 are both complementary to angle 2, then that means that 1 is congruent to angle 3. All right, vertical angles theorem. This says that if we have 2 lines that intersect, 1 and 2 will be congruent to each other. And we also know that 3 and 4 will be congruent to each other. So when you have these vertical angles, 1 and 3 are not vertical angles, right? Vertical angles are the ones that cross from each other. So 1 and 2 are vertical angles, 3 and 4 are vertical angles. If I have perpendicular lines like line L and line M, and if they are perpendicular, we know that we have formed 4 right angles, okay? This is kind of the same situation, right? You can say that if I've got two perpendicular lines, we get 4 right angles, but you couldn't say if we have two perpendicular lines, we get 4 angles that are 90 degrees. You'd have to first use this perpendicular lines form 4 right angles reason to establish right angles, and then you can establish that right angles are all congruent. You could establish that right angles are all 90 degrees, but you have to, again, take that intermediate step. All right. And then the last one, obviously, all right angles are congruent. They're all going to be equal to 90. All right, the last two, all right, if two angles are congruent and supplementary. So if one is congruent to 2, and if they are supplementary to each other, then we know that 1 and 2 are going to be right angles. All right. And then the last one, if two congruent angles form a linear pair, so they're adjacent to each other as well. That's why, notice I have them sharing a common ray here, and the one above, they don't share a common ray. So if they form a linear pair, then each angle is going to be a right angle. All right, so those are all the new reasons we have. If you, I mean, it'd be a great idea if the class as a whole could maybe make like a Google document and, contribute to that Google document with all the reasons, because it's easy when we have just a long list of all the reasons, like throw on the segment addition postulate and the definition of congruence and the vertical angle theorem, and keep throwing all these postulates and theorems and properties on the same spreadsheet, on the same Google Doc. That way you can have this compiled list of all the reasons you could possibly use. It's going to make your life a lot easier, so you don't have to keep flipping through all your notes and trying to find all the reasons, okay? So let's try this next proof. This is actually a proof of the congruent supplements theorem, okay? So remember, the difference between theorems and postulates is that postulates are just accepted to be true. Theorems, you can actually prove them to be true. So we're actually going to prove that this statement here is true, all right? So what they give me, they tell me that angles 1 and 2 are supplementary. They also tell me that angles 2 and 3 are supplementary. So in my statement column, I'm going to say angle 1 and angle 2 are supplementary. And I'm also going to say angles 2 and 3 are supplementary. All right, reason is obviously given. All right, so now I'm thinking, well, all I know right now is this information, so it's got to build off this, right? I'm trying to get closer to saying 1 and 3 are going to be congruent to each other. So really all I know is that they're supplementary, and that's going to have to mean that the measure of angle 1 plus the measure of angle 2 is equal to 180. And I also know that the measure of angle 2 plus the measure of angle 3 is also 180, right? This is the definition of supplementary, right? We know that what supplementary means is that two angles will add up to 180 degrees. So I'm allowed to say this because that's what the definition tells me. So now, again, I'm trying to get closer to having 1 and 3 in the same mathematical statement. So I see a 1 and a 3 here, so I'm going to try to combine these equations. And since they both equal 180, they must equal each other. So again, tempting to say substitution, but when in doubt, transitive property, right? They both equal 180, so they must equal each other. That's transitive. So measure of angle 1 plus measure of angle 2 equals measure of angle 2 plus measure of angle 3. All right, the reason is transitive. All right, and now if I'm looking at this, well, I see that they both have a measure of angle 2 on both sides, so I could probably just subtract that on both sides. So now I'm going to say the measure of angle 1 equals the measure of angle 3. That was just subtracting. All right, and then the last step, I'm pretty close. I'm just going to say that angle 1 is congruent to angle 3, and that's just the definition of congruence. All right, and we did it. All right, that's the last one. We're not going to do this last one here. Again, good luck with the homework. If you have any, all the answer keys are there, so you can take pictures of the answer keys in the textbook if you'd like. Obviously, you can come in for extra help on Friday morning. I'll be there. And yeah, good luck with the homework. Feel free to work on it with a partner. Or if you're getting stuck, you can always just Google, examples to do with proofs and stuff like that and find some other good examples to try.